Welcome to Chapter 2, Surface Area. This is our first chapter on geometry that we're doing this year. And in this chapter on surface area, first thing we're going to be looking at is the views of 3D objects, which is what today's lesson is going to be all about. And then after that, we're going to be looking at how to create nets to model 3D objects. And then from there we'll be moving on to determining the surface area of a prism, a right prism, and after that determining the surface area of a cylinder. So as I mentioned, today we're going to be looking at the different views that we take of that we can take of 3D objects. So when it comes to three-dimensional images, they are very, very important in everyday life. Visualizing, simulating, and rendering graphic designs by creating an excellent illustration of any item or shape gives three-dimensional images an edge over two-dimensional images. So stakeholders can experience what the structure will actually look like way before the item is actually constructed. And 3D imaging also allows early detection and resolution or solving of clashes or problems before a whole lot of money is spent on creating the actual object. Doing a 3D prototype can allow for early detection and problem solving. And 3D printing, as you all know, is a very exciting technology which can allow us to manufacture prototypes or even finished products quite cheaply and even in our own homes or in our own library. So how do architects use 3D and 2D images? Well, architects, their first step in designing a building is that they would visualize and sketch a 3D drawing for that building before they move on and create more detailed two-dimensional blueprints. So the image at the top is a 3D image of a building, and then the image beneath it is a two-dimensional blueprint. So what's the difference between 3D and 2D? Well, 3D objects have height, they have width, and they have depth. So they have three dimensions: height, width, and depth. Whereas 2D images usually only have two dimensions, being width and depth. An elevation is a sketch of the front or side of a building, so it is only two-dimensional. So what are the learning outcomes for this 2.1, the views of a three-dimensional objects? Well, first of all, you need to be able to visualize and describe the views of 3D objects using mathematical vocabulary. So you need to learn the vocabulary that is unique to 3D objects, the mathematical vocabulary, and you need to be very comfortable using it to visualize and describe the views of 3D objects. Then you also need to be able to draw and label the top, front, and side views of 3D objects. And then you need to be able to build and sketch 3D objects when you're just given the top, front, and side views. So these are mathematical skills, even though there isn't number crunching involved. Being able to model objects accurately is a mathematical skill that is required in this section of the curriculum. So let's get looking at the vocabulary associated with the views of 3D objects. So the key points that you need to get from today's lesson is that you need a minimum of 3 views to accurately describe a three-dimensional object. You can build or draw a three-dimensional object by using the front view, the top view, and the side view. Those are the three views that we need: top, front, and side, in order to accurately describe or model a 3D object. In addition to the vocabulary associated with the top view, the front view, and the side view, there are other parts of 3D objects, the vocabulary of which you need to be comfortable with. So if you look at this diagram here that shows you various three-dimensional shapes, you can see some of them. The cube has got 6 faces, 8 vertices, 12 edges, whereas a cylinder only has 3 faces, no vertices, and 2 edges. So what does this mean? Faces, vertices, edges. What does that vocabulary mean? Well, your faces are your flat or curved surfaces. So any flat or curved surface in a 3D object is called a face. Then your edges are the line segments where 2 or more faces meet. So your edges are the line segments where 2 or more faces meet. Then the points where 3 or more edges meet are called vertices, which is the plural of the word vertex. So if it's a point, if it's 2 surfaces coming together at a point, that is a vertex. And if it's 2 surfaces or faces coming together at an edge, we're forming a line segment, that's called an edge. Since some of the views in a regular simple 3D shape are the same, a minimum of 3 views are needed to describe a 3D object. So we typically use the top view because usually the bottom view is the same, and we usually use the front view because typically the back view is the same, and we also use a side view because the other side view is the same. So one of the learning outcomes is that we need to be able to draw and label the top, front, and side views of 3D objects. So we can use grid paper to help us draw out the different views of a 3D object. So the first object that's given to us over here is the pizza box. And we can see the top of the pizza box. We can see the front view of the pizza box, but we can't really see the side view. But even though we can't see the side view, we have to be able to represent that side view if we're asked to do so. So what shape would the side view have? Well, because the top of the pizza box is a rectangle and the side of the pizza box is a rectangle, the front of the pizza box is a rectangle, we know that this side here is also going to be a rectangle. So our solution, we need to label it. So we draw a rectangle for the top, a skinnier rectangle for the front, and another skinny rectangle for the side view. So how about image B? This is what's known as a triangular prism. So prisms are usually named for the shape of the base. So this is or one of the sides. So this is a triangular shape. The pizza box A would be called a rectangular prism, and sometimes they're also called cuboids because its side or base is a rectangle. So if I am looking at this triangular prism from the top, what I'm going to see is 2 rectangles separated by a line through the middle. And when I'm looking at it from the front, I can see a triangle. And when I look at it from the side, I also am seeing a rectangle. So this is what my front view, top view, and side view would look like. The top view is going to look like a rectangle divided through the middle. The front view is a triangle, and the side view is also a rectangle. So how about this glass of water? If we look at the glass of water from the top, what are we going to see? We're going to see a circle. If we look at it from the front, it just looks like a rectangle. And if we look at it from the side, it's also going to just look like a rectangle. So this kind of 3D object is called a cylinder because the base is a circle and the side view is a rectangle. So if we have to represent this using a top, front and side view, our top view is a circle, our front view is a rectangle, and our side view is a rectangle. So that's how we would draw and label top, front and side views if we're given a 3D object. Sometimes we are given something that looks like this. It looks like a whole lot of blocks kind of put together, and we have to be able to use grid paper to draw the top, front and side view of the object. So this can be a little bit tricky, but we have to just stay really disciplined in our imagination and take a look at the different views. So a useful tip is, before you start drawing, is to color all your top views the same color, all your front views a different color, and your side views a different color. So in this diagram, we have all the blocks that we can see from the top color-coded blue. All the blocks we can see from the front are yellow, and the ones we can see from the side are green. So when I draw this on grid paper, first thing I'm going to do is draw my top view, and I've got 1, 2, 3 blocks that I can see attached to each other on my top view, and then another 2 attached to that top block going to the right there. So it's 1, 2, 3, 4, 5 blocks attached to each other in the shape of an L. Then my front view, I've got 1, 2, 3 blocks attached to each other on the front, and then another 2 attached at the base, also in the shape of an L. And then my side view, my green blocks, I've got 1, 2, 3 green blocks attached to each other, and then I've got another 2 green blocks and 1 green block. And so that's how I would represent that 3-dimensional block shape on a 2-dimensional grid paper. So what I'd like you to do now is to take a moment, pause the video, and actually try to do this on your own. Use a blank paper or grid paper to draw the top, front and side view of the bench. And then after you've done that, use the grid paper to draw the top, front and side view of the object. And they've already color coded it for you. So pause the video and try to do those on your own. And when we come back to the video, it will show you what your results should be. So how did you go with drawing your 3-dimensional objects? Drawing the 3 views, the front, the top and the side view. So your bench, did your bench look like this? Have you things to check for? Have you labeled your views, top, side and front? If you have just drawn the shapes there and it's not labeled, you're not going to get marks for that on a test. You have to draw it and label it. Okay, so your front view of the bench looks like that. It didn't give you actual dimensions, so it doesn't matter if the number of blocks you used is not exactly the same as I have here. So long as your side view is the same height as what you have here on your front view, and your top view, so long as that's the same length as what you have there, and so long as your depths here are the same. So you can see on the side view here I've got it's 2 blocks wide, so your top view also needs to be 2 blocks wide. You could have chosen to just do 1 block wide, but then your top view would also have to be 1 block wide. Okay, and then how about these blocks, modeling the top, front and side views? So the top view, which is the blue blocks, there were 3 of them, 1, 2, 3, attached to each other. And then the front view, which is the yellow blocks, there were 2, and then 3 next to that, and then 1 next to that. And then your side view, there was 1, 2, 3 green blocks, one on top of the other, 1, 2, 3. So before we move on to building and sketching 3D models, I'd like you to complete the practice exercises associated with this learning outcome, where you have to draw and label the top, front and side views of the 3D objects. So these practice exercises can be found on page 42 and 43 of the textbook. So you are required to do question number 1, and then question number 2 you have to do A, and then you can choose to do either B or C. The choice is yours. And then question number 3, you can choose to do either A or B or C or D, so just one of those. And then on page 43 you can choose to do either question 7 or question 8. So once you've completed those practice exercises, go and check your answers in the back of the textbook to make sure that you're correct, and do the corrections. And then complete this confidence self-assessment. How are you feeling about this particular learning outcome? Are you very confident? Do you feel somewhat confident or not confident at all? Once you have completed that, you can come back to the video. Right, so you should have completed the practice exercises from learning outcome 1. So we are going to move on to the next learning outcome, which is that you have to be able to build and sketch 3D models if you're given the top, front and side view of the model. So we can do this. We can build the model using blocks or cubes, or we can draw the model. So here we have an example where we're given an object, and if you look at the front view, it has got 10 blocks in it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can take 10 blocks and build a model to represent this 3D image. So this is what, if we took out 10 blocks, this is what it would look like. You can see the front view is the same. Our top view has got 1, 2, 3, 4 blocks, 1, 2, 3, 4. And our side view has also got 4 blocks, 1, 2, 3, and 4, all on top of each other. So obviously on math tests it's going to be very difficult to expect you to build 3D models using blocks and hand that in. So usually on a math test you're going to be asked, you're going to be given the top, front and side views, and you're going to be asked to sketch the 3D models. So to draw the 3D object, we have to have all 3 views visible. So the top view, the front view and the side view. So in order for this to achieve this result, we have to draw the image of the object as seen from an angle. And this view is called the isometric view. And it's accomplished by rotating a cube so that all the sides are seen equally. So if we were drawing a 3D model of just 1 block, we draw the front view like this, and then we would add depth lines and then join those depth lines together. So we would draw a depth line from each corner of the face of our cube and then join those depth lines, and that would create our 3D image. So that's a very simple sketch just of one block. So step 1, draw the front view of the block. Okay. Step 2, draw your depth lines going from the corner so that we can create a top view and a side view since we already have a front view. And then we join those depth lines together in order to create our top view and our side view. So how do we do this for a more complex 3D model? So here we have a more complex 3D model where we're given the top view that's got 3 blocks. We're given the front view which has got 5 blocks, and then we're given the side view that has got 2 blocks. So the first step is to draw the front face of the 3D object. But remember, we're rotating it and looking at it from an angle. So we draw those 5 blocks. It's 2 blocks high, 1, 2, and it is 3 blocks wide. So 1, 2, 3, and 2 blocks high, 1, 2, and then the top leg over there is just 1 block wide. We go down and another block wide and we go up. So there we have our front view of our 3D object. Step 2, we're going to draw depth lines from each face to form cubes. So there's my depth line from my face there, from my 1 point. There's another depth line. I'm going to draw a depth line over there, a depth line over there, one from that corner, one from that corner, and one from that corner. So because this object is only 1 cube deep, I know it's only 1 cube deep because my side view is just 1 cube wide. I just draw my depth lines one cube wide. And then step 3, I connect the depth lines to complete the object. So I'm going to connect all my depth lines, and there is my 3D object. My top view is correct. My top view, if I was looking at this from the top, should have 1, 2, 3 cubes. And if I look from the top, 1, 2, 3. My front view, I've got my 5 cubes. My side view, I've got my 2 cubes. So I know that I'm right. So just a reminder, the 3 steps is you draw the front view first, okay? You're at an angle, so we've got 5 cubes, 1, 2, 3, 4, 5. Then the second step, we draw our depth lines. And then third step, we join our depth lines to finish off the object. So please pause the video now and take a moment to try to complete the 3D image given these top, front and side views. When you're finished, please come back to the video to check your answer and see if you are correct. So how does your picture compare with this? So the starting point is to draw your front view. Okay, so my front view, my blocks are 3 tall, or so I would go 1, 2, 3. And because it's a side view, it's not going to go in a straight line, it's at an angle, and that is 3 blocks deep there. So 1, 2, 3, and 3 blocks high, 1, 2, 3, 1, 2, 3. and then you've got your middle block, which is empty there. So that's my front view. Then I'm going to create my depth lines from every face. So 1, 2, 3, 4, 5, 6, 7. There's my depth lines, and I'm only going to draw them 1 block deep because my side view is only 1 block deep. And then third step is to join all those depth lines, and there is my 3D object. So mine is kind of showing at an angle with the left side visible. You could have drawn yours from an angle with the right side visible. That would also be correct. Right, so it's time for you to complete the rest of the practice exercises associated with this 2.1. So you're going to turn to page 42 in your textbook, and you're going to answer question 4. And then on page 43, answer question 5. And then question 9, you can choose whether you do A, B, or C. You just have to do A, B, or C. You don't have to do all of 9. Once you've done that and you've marked your answers and you've done your corrections, please do the self-assessment. And then go on and do the questions associated with this learning outcome, where you have to visualize and describe the views of 3D objects using mathematical vocabulary. So these exercises on page 43, you have to answer question 6, and then you have a choice whether you're going to do question 10 or question 11. Then mark your answers and complete the self-assessment. Once you've done all of these exercises, you've marked them, please bring your practice exercises to me, and then I will give you the exit sheet, which is also going to act as your quiz.